We finish up this unit on severe weather, talking about Midwest severe weather. And if you're like me, you kind of like some of this, these thunderstorm activities. So we'll see if it kind of conjures up some images. And if nothing else, hopefully that when spring comes and we get some of this weather, you'll be like, oh, that's what that looks like. So by definition, I think it's funny that we are not afraid, but a thunderstorm, like, oh, but the thunder isn't what gets us. Of course, it's the lightning. So a thunderstorm, thunder, and we'll talk about that coming up. Actually, thunder is the audible part of lightning. Okay, so thunderstorm. If we are having a thunderstorm, you may expect heavy rain, hail, and I want to talk a little bit, I want to differentiate hail from sleet, and or we might have tornadoes associated with thunderstorms. So the thing about it is, we've been talking about, anytime you see a milky white cloud, either think that gas has gone to liquid, we call that of course condensation, or maybe gas has gone ultimately to a solid, and then of course that means we have ice crystals up there. We call that what? The Bergeron process. I'll put P for process. Anyway, the reasons it's milky white is because you either have water that is in its liquid state or its solid state. But that's not my point. My point here is anytime you go from a gas to a liquid or a gas to a solid, actually that is what we call exothermic, or heat is released. So heat released. Yeah, we actually call that the latent heat of either condensation or latent heat, I guess it would be of deposition if it goes from a gas to a solid. But my point is, I'm going to circle the word heat here. And what do you know about warm air or heat in your house? Warm air in your house will rise. And so that's exactly what's going on with regard to the chunk of air that has either condensation or deposition going on, or crystallization going on. Is it's warm and it's going to rise. We talked about different lifting mechanisms, and one of the lifting mechanisms is if it is warmer than its surrounding, it's going to rise. So of course we call that chunk of air unstable, and the more it rises, the more it cools. Remember, as it rises, it expands, and as it expands, it cools. And we can get more condensation, and then that actually release more heat. Okay, so that's kind of how that all works. Very unstable. We're going to talk about, we're going to start with the cell, just a little individual cell, and then actually later on we're going to talk about actually these thunderstorm cells oftentimes come in sets, storm systems. And when we talk about the thunderstorm cell coming up here in a minute, just an individual cell, it's going to start as a cumulus stage, go to the mature stage, and end as a dissipating stage. And like I said, if you haven't recognized it before, I'm hoping that you kind of recognize these different stages of a thunderstorm cell, maybe next time we experience thunderstorms. Okay, so starting with the cumulus stage. Cumulus, by the way, remember that's a type of cloud. Cumulus, what means fluffy? Okay, so the cumulus stage is the beginning stage. There's no precipitation happening here with this thunderstorm cell. Cumulus stages are noted just for having what we call an updraft. And so here you can see these little red arrows going up. That is your updraft. Okay, yeah. So remember what happens as a chunk of air rises. A chunk of air rises catching this updraft, and actually it expands, and as it expands it cools, and as it cools it can go ahead and reach the dew point temperature, or reach that point of the air being saturated because it's cooled to that point. And then I'm going to go ahead and erase all these strokes. And then actually we can have condensation. Now the elevation, and I talked about this before, I called it the LCL, the elevation at which we have lifted the chunk of air and it expanded to the point of cooling, to the point of reaching, 100% relative humidity. Okay? So 100% relative humidity got our condensation. That's why it looks milky white. So I hope this all is kind of working for you. So I don't think I mentioned it before, but oftentimes clouds, especially cumulus clouds, will have this nice flat bottom. Okay. Now, you've noticed, I'm sure because I have, sometimes these cumulus clouds have these, they're puffy and they have these wonderful crisp edges. Now, meteorologists will tell you that the more crisp the edge, the more recent that chunk of air has punched through the atmosphere. So kind of the more recent the development, the more crisp the edge. Okay, so hopefully you can compare that previous figure with this figure. Now this figure actually then is showing the thunderstorm cell as it is in its mature stage. And its mature stage, as the word implies, that's when you're going to have the most significant activity with the cell. So notice, let's start at the beginning, we still have our updraft. Okay, so it's what we say being fed by probably warm, moist air. It's being fed, and then that moist air expands as it rises and cools, and it cools to the point of condensing, and as it condenses then it warms, and it makes the chunk of air even more buoyant and want to rise. So it kind of what we say a positive feedback sort of thing going on there. But anyway, in its mature stage, now we have an important feature called the downdraft. So the downdraft here is represented in blue arrows. So with the downdraft, now how do I say this? The way I think of it is up here in the clouds, basically your liquid water droplets or ice crystals have become heavy enough so that gravity takes over and the updraft is no longer sufficient to keep them in the cloud, and so then they fall down. So the downdraft literally is associated with particles, liquid particles and maybe ice crystals that are falling from the cloud, and they literally create this wind, this downdraft, as they come. Okay, so downdraft is associated with precipitation. Notice that we have this feature called, if it's in its mature stage, it's basically punched through the, I'll put a T for troposphere, and I'm going to put a dot up here at the top of the troposphere. I'll put a S for stratosphere up here. And remember, what separates the troposphere from the stratosphere is the tropopause. Tropopause. So if you've ever, and I bet you have, seen this thunderstorm cell kind of flatten out somewhere, that kind of invisible flattening out is because it is bumping up against the tropopause and flattening out. And as it flattens out, it creates these features we call anvil, an anvil feature. And I have a figure coming up here, but these are anvil features. And the longer anvil, I know it looks like here I've got an anvil on either side, but the longer anvil actually is pointing in the direction that your storm cell is headed. Okay. So I am going to come back to another figure of a mature stage of a thunderstorm cell coming up. But in a mature stage, we can get this phenomenon called hail. Now, like I said, I even hesitate to mention the word sleet. Sleet and hail are totally not the same thing. I hope you remember what causes sleet, and that's basically, let's see, how's that work? Precipitation falling from a cloud, it melts, and then it refreezes before it reaches the ground. Hail is much more awesome. Hail is only associated with thunderstorm cells. And let's kind of pull the rest of this up here. Hail actually starts as a piece of grapple, and grapple, you might have seen grapple fall from the cloud before. It looks like kind of, I think of it as misshapen ice crystals. That's what grapple is. And what grapple does then is it basically kind of, and here's the path in purple here. Piece of grapple falls, and it goes up, and then it falls, and it goes up, and then it falls. And actually what's happening is it is right here, before it totally falls from the sky, it is caught in the updraft. But the reason it falls is because it got a little bit larger, and gravity kind of takes hold of it, and then it catches a stronger updraft. It goes up and down and up and down. Now, what makes it larger actually is the presence of, I think this is so awesome, the presence of what we call supercooled water. Now, There are some super states in physical science, and a super state means it's probably outside of what you think it should be. So super cooled water means that it's cooler, actually, excuse me, it's its liquid state at a temperature cooler than we really think it should be. So it's liquid water at temperatures like, I don't know, -4 Celsius, -20 Celsius, which is really crazy. And when I think of supercooled water, I think of, and I haven't flown much, but when you fly, they coat the wings of the plane with this liquid. It's an anti-freezing sort of liquid, because basically, as your plane is flying, it's going to fly through clouds that have this supercooled water. And one of the things about things in super condition is they tend to want to come out of their condition with not much help. So a plane flying through supercooled water will basically coat its wings with ice if it's not treated like that. So anyway, so bottom line, this purple right here, this purple kind of shows it going, the piece of grapple going down, because it got heavier, and then it goes back up. It catches a strong updraft. It gets heavier. It falls back down because of gravity. It catches a stronger updraft. It goes up. Okay, you get the idea. So it ends up basically going up and down several times. And I don't know if you can see it very well, but hail should really kind of have this kind of onion look, kind of a layered look. And each layer, like if you could count the layers, like you count the tree rings to know how many years that the tree has lived, how many cycles, you can count the layers in hail to know how many times it's gone up and down. I just think that is so cool. So bottom line is, how big can your hail get? Okay, how big is it going to get? Well, that depends on how strong your updraft is. And your updraft is related to instability within the cloud. So the stronger, the more unstable the air, the larger the hail can grow. All right. So the last stage is a little bit boring. So we have the cumulus stage, just an updraft, fluffy cloud, lifting condensation level, that sort of thing. And then we have the mature stage where we have our activity going on. That's a mature stage is when you're actually going to have your precip, your lightning, your hail, and then we have the dissipating stage. Now, if you were to compare this one, hopefully, with the mature stage, you're going to notice that all it has is a downdraft. No more updraft, so no more feeding. So the dissipating stage is actually the beginning of the end. You kind of have just light rain going on. Okay.